Hello, we're going to talk about how to prove triangles are similar by what we call AA. It's an angle-angle similarity postulate. So here's what the postulate says. If two angles of one triangle are congruent to two angles of another triangle, then those two triangles are similar. So as you can see here, I've got angle K and angle Y are congruent, and then angle J and angle X are congruent. So we know that by the third angle theorem that angle L and angle Z are also congruent to each other. So we've got all angles are congruent, and then because triangles are unique shapes, we also know that their sides will be proportional. That's what this postulate says. Notice that if we know that, then we can write that triangle JKL right here is similar, remember that little squiggle means similar, to triangle XYZ. So let's do a proof using this postulate. So we're given that angle B and L are right angles, and we need to try to prove that this triangle ABH is similar to KLH. So we're going to start by writing our given. Angle B and angle L are right angles, and that's just given. And then what else do we know in this diagram? Let's take a look at this diagram. We've got vertical angles right here. So I need to also list those vertical angles. That would be angle AHB is congruent to angle KHB, or I'm sorry, KHL. And we know that with the vertical angles theorem. So let's see if we have enough. We have one set of angles are marked congruent. Now, we said that B and L are right angles, but we didn't say that they're congruent. It may seem obvious to us, but we need to say that angle B is congruent to angle L, and we know that because they're right angles. Remember, that's called the right angles theorem. So now we can say that these two triangles are similar. Notice that we're saying they're similar, not congruent in this proof. And that's by our new postulate called angle-angle similarity. So let's do a few more examples using this new postulate. So we're going to decide whether these two triangles in each problem are similar or not. Now notice that we need to know if two angles are congruent. And so far, we only know that this 92-degree angle is congruent to this 92-degree angle. Now, we don't know that third angle, so you need to use the fact that all the angles in a triangle add up to be 180. So I'm going to do 180 minus 92 minus 57, and that will give me that this angle is 31. And then I'm going to do the same thing over here in this triangle, 180 minus 92 minus 41, and that gives me 47. So you can see that we really only have one angle congruent, so that means that no, these are not congruent or not similar triangles. Okay, I'm going to use that same strategy for B. I'm going to find that third angle by subtracting those from 180. So if I do that, we get that all three angles are congruent. Okay, when we have at least two, we only need to have two for angle-angle. So I know 48 are congruent, and you could say like 77 are congruent. So yes, these are similar triangles. And then we will do that same strategy for part C. So I don't have anything congruent right now. And then if I do 180 minus the 70 minus the 67, I get that this third angle is 43. So I've got 43 is congruent. However, I don't have enough information in the second triangle. So I can't say that those are congruent or similar at all. So I'm going to say no on that one. We don't have two sets of angles that are congruent to each other. All right, now in this diagram, it says that these two triangles are similar. And let's make sure we know what we're talking about. We're talking about this big triangle, L and P. I'm going to draw those out separately. And then we also are talking about triangle M and O. Okay, so those are similar triangles, and they want us to list all of the congruent angles. Well, that would be angle L is congruent to angle M, and then that would mean angle N is congruent to itself, And then I also have angle P is congruent to angle O. So those are the angles, and then we also need to list the sides that are proportional. So LN is over MN, and that would be proportional to side NP, which corresponds to NO, and then PL would correspond to OM. So that's our statement of proportionality. All I did was list which sides would be corresponding and proportional to each other. So let's go on to this next diagram. And we're going to decide, okay, if these two triangles are similar and what do we know about them. So MON, this is the first triangle. Notice that we know two different angles are congruent. So we do know those triangles are similar. So I would say MON is similar to triangle GHI. So because of that, I know all of the angles are congruent, and then I know these sides are proportional. So MN is going to be divided by GI, or proportional, or the ratio to GI that corresponds to that side. And that's proportional to ON over HI, which is proportional to MO over GH. So now we're going to actually fill in some side lengths because they have given that to us. So if I look at 16, side 16 corresponds to side 12 in that triangle. So I'm going to put 16 over 12. And then I also need to look at the side 10. What does that correspond to? That corresponds to side X. So X goes right there. And then I also need to look at this second set of proportions. Again, I'm looking at side 16, and we just said that that corresponds to the 12. And then now I'm looking at the side 8. Side 8 corresponds to side Y. So I'm going to put that there. And now we need to solve. So for the first proportion, we're going to cross multiply, get 12x equals 160. Divide both sides by 12, and we get 13.3 repeating. And then for the second proportion, we cross multiply, and we get 12y is equal to 128. Divide both sides by 12, and that gives me 10.6 repeating. So now move back to the back page of your notes. And we're going to look at these examples. See if you can try them on your own before I begin them. Go ahead and pause the video, and then we'll come back and discuss them. So on this side, on all of these examples, you should be using the strategy that all the angles add up to be 180. So we know that in triangle ABC, that angle is 47, and that this angle is 43. So yes, these are similar. And then I can say triangle ABC is similar to triangle ZYX. Be careful how you list those. The order does matter. All right, again, I'm going to find that third angle. That's 72. That's 82. So again, I don't have enough angles congruent to each other, just the 35. So that's not enough information, so we would say no, these are not similar triangles. And then over here, again, I'm going to find that third angle. That's going to give me 50. This is 45. So I've got all three angles congruent. So yes, those are similar. And I can say for my similarity statement that JKL is similar to triangle YZX. Now on these bottom ones, we have some overlapping triangles. So if it's confusing for you to see them like this, go ahead and draw them out separately. The important part of number 10 is that we have parallel lines. These are the parallel lines. And we have two transversals. I can use this transversal. Remember, that makes that F shape. So I would have corresponding angles there. And I could also use this other side of the triangle with my parallel lines. And that makes another F shape. So I have another set of corresponding angles. So what I really have is I've got this smaller triangle on top. That's JKN with those two angles congruent. and I have that larger triangle, which is JML, and those also have those same angles marked congruent. So these are indeed similar. So I'm going to say that triangle JKN is similar to triangle JLM. All right, so let's look at number 11. 11 might be harder to see. Again, I'm going to redraw these out. I'm going to draw that little bitty triangle. It's kind of harder to see. That is a 45-degree angle. This is 50, so I'm going to find that third angle, which is 85. So this is triangle POQT. That looks like an O, doesn't it? And then I'm going to draw that bigger triangle, which is RPS, and this angle was 85. This angle up here was 50, and then S, if I subtract that from 180, that gives me 45 degrees. So these, again, have all of the same angle measures. So I can say that triangle PRS is similar to triangle PTQ. All right, one more of these type. I've got one of these bow tie situations, and if I have parallel lines, we can look for that Z shape. Remember, these are alternate interior angles. And I've got that other transversal I can use. So once again, I have at least two sets of congruent angles. And we even know these vertical angles too. So if you wanted to use those, you could have used those. So we could say, yes, these are similar. So triangle GHK is similar to triangle NMK. All right, moving on with a different kind of example. Here we're trying to find the length of BC. So we don't know how long this segment is BC. So I'm going to put a little X there because that's what we're trying to find. That's our unknown. Now first we have to figure out, are these triangles similar? Can I even make a proportion? Well, this is like that bow tie situation again. So we've got alternate interior angles, so we know that those triangles are similar. Now what might help you is to redraw that top angle so it's oriented the same way. So I'm going to put that single arc and then the double arc over there. So that single arc up in the top triangle is angle B, and the double arc is angle A, and the middle angle with the vertical angles, that's C. So that might help us. So BC is what we're trying to find. That's what we labeled as X, and AC was 4. So now it might help us set up this proportion. So X corresponds to 5 there. So X corresponds to 5. And then the 4 corresponds to 7. So if we solve that, we're going to get 7x equals 20. Divide both sides by 7, and we get 20 over 7. So our answer should be D. And now for our last example. We've got this complex diagram with a flagpole and a guy. And we're trying to estimate the height of this flagpole, and we're talking about his shadow. So remember, shadows are down on the ground. So this would be the guy's shadow, and the whole length along the ground would be the shadow of the flagpole. So they're saying that they coincide so that the tip of the flagpole shadow is the same as the tip of the guy's shadow, right there at point A. So we have two similar triangles. So let's draw those out. We've got this little bitty one, and that's with CAB. And then we have the larger one for the flagpole, and that is DEA. So why would these be similar? Well, we've got the right angles because we're assuming that the flagpole and the guy are standing upright, perpendicular to the ground. And then we also have this angle A that was in both of them. So this angle A is congruent to that angle A. So we know these are similar triangles because of the AA similarity theorem, because angle A is congruent to itself, and because angle C is congruent to angle E. Those were both right angles. Okay. So now we're going to use these triangles to write a proportion that models this situation. So here's where we're going to fill in the feet that we know. So this side right here, that guy's shadow is 6 feet long, and the guy is 5 feet tall. And then for the larger triangle, the flagpole shadow, that whole thing along the ground, that's a total of 18 feet. We added 6 plus 12, and then we don't know how high the flagpole is. That's why they mark that with H. So I'm going to put H over there. So if we create a proportion, we're going to say H corresponds with 5, and 18 corresponds with 6. So now we're ready to solve this proportion by cross multiplying. So that's going to be 6h is equal to 90. I did 5 times 18. And then divide both sides by 6, and I get 15. So our flagpole is a height of 15. And now you have a new creative way to measure how high a flagpole is without getting out your tape measure.